Hello, everyone. I'm Julie Rick. I'm a teacher in San Diego, California. I teach at a middle school, sixth grade at Marshall Middle School. And I have the pleasure of introducing to you our guest speaker today. Her name is Jenny Moore, and she is a retired naval fighter pilot. Hi, Jenny.
Hi, thanks for having me today, Julie. My name is Jenny Moore. My call sign is Juno. I'm currently an F-35 instructor pilot. I work with all the services that fly the F-35, Air Force, Marine Corps, Navy, and I'm excited to talk to all of you today.
All right. All right, Jenny. Can you tell us a little bit more about yourself?
Absolutely. So as Julie said, I was a Navy fighter pilot for most of my adult career. I started out at Georgia Tech studying aerospace engineering. While I was there, it was much more technical. I learned how to design and build airplanes and all the complex aerodynamics that go into airplanes and space vehicles. Then I went from there, I joined the Navy right out of college, and I started teaching at nuclear power school. So my first job in the Navy was teaching physics and reactor dynamics. But I absolutely loved airplanes. I still really wanted to fly and be part of aviation. So I went to flight school. So I found myself being a student again. After teaching for a while, I went back to flight school. I was there for about 2.5 years as a student. Then I went on to fly F-18s, combat operations, aircraft carrier operations, and I was also an instructor in the F-18 in the aircraft. After I got out of the Navy, I joined Lockheed Martin as a civilian F-35 instructor pilot. So now I still am back to teaching, I teach all of the academic classes, and then I instruct in the simulator and support all of our F-35 training worldwide. So I've had a lot of experience as a student, and I've had a lot of experience as a teacher. And so today I was going to share some of that and talk to you about carrier operations and how we involve math in that.
Great, Jenny. Can you touch upon how your education prepared you for your career as a naval fighter pilot?
Yeah, it's funny. I went to college for aerospace engineering where I learned how to, build aircraft. But then when I got to flight school and I started flying airplanes, I realized that most of what I had learned in, sixth grade, the grade that you're teaching right now, sixth grade, seventh grade, eighth grade, is the math that I needed to use day to day to get through flight school and to get through my flight training. So some of the things that we have to do when the big thing is our aircraft is very sophisticated. We have a lot of instruments and computers that are available for us to help do all of the things that we need to do, navigate ourselves from A to B, how fast are we going? But there's a lot of times when things change rapidly that we have to be able to do the math in our head. The big thing is, though, even using all of those systems that I have in the aircraft, you have to type everything in correctly. And while you're trying to fly a plane, keep track of another aircraft in the sky, talk on the radios, and input all the data you need for your aircraft to do all of those calculations for you, it's really easy to make a mistake. Imagine if you were riding a bike and trying to do a math problem with your calculator while you're riding your bike. And so there's a good chance that while you're, riding your bike and doing other things, you're trying to type in that calculator that you might miss some numbers. And so then when you get the answer, you need to know, ooh, that is not the answer that I expected. And I probably did something wrong. And so that's kind of a constant process that we're doing as aviators, as pilots, every day, just sometimes flying from A to B, or even in more complex scenarios.
So that's music to every teacher's ear, because you're talking about, does your answer make sense? So much of what we do is asking the students, if your answer does make sense. And it's nice to hear these connections between our classroom and careers.
Yeah, absolutely. I heard the same thing when I was in, growing up in math, and why can't I just use my calculator? It's so much easier. But I will tell you, I do so much mental math every single day, and I have all the instruments available. But sometimes they, like I said, they only will give you good information if you put good information into them. And sometimes in our scenarios, and I'll talk about them a little bit here, we just don't have the time to input things in and have the systems work for us. So you have to be able to very quickly just do the math while you're doing other things and distracted. And I am much better at adding and subtracting in my head today than I was then, because I've had lots of practice.
Well, let's look at some exciting video here.
All right, so this is just to show you guys, for those who are not familiar, what an aircraft carrier environment is like, or what airplanes, what it's like, what it looks like. We want to show you some video just to show what it's like to land on an aircraft carrier. Then I'll talk about some of the things that we do leading up to that. So this is just some video as an example for what it looks like around the carrier environment and what it looks like when an aircraft is landing on the aircraft carrier. There's going to be some videos of F-18s and F-35s, which I've been working with both of them. And I just wanted you guys to be able to see what it looks like.
Awesome, Jenny. Thank you. All right, Jenny, can you touch upon some concepts that you learned from like late elementary school to middle school that you find are really critical in your job?
Absolutely. So one of the things that we do, I showed a little bit of video of what it's like to land on an aircraft carrier. And when we are doing a recovery, is what we call it, when the airplanes come to land on the carrier, usually we have a bunch of aircraft that are airborne. And when the airplanes are landing, the ship has to be driving in one direction to make the wind over the deck exactly what it needs to be. And it has to do that for the entire recovery window of all of the aircraft. That means that all of the aircraft need to be able to come in and land as quickly as possible, while also doing it safely. So what they do, and what you can see on the left side of the slide here, is the pattern that we fly around the aircraft carrier when we're coming into land. And you can see up there at point A, they're going to send all of the airplanes to a place in the sky for us to hold. And that point A is our starting point for our descent into the aircraft carrier. And our goal is to have an airplane landing every 60 seconds on the deck. And so it's very important that when they tell us to hold, they're going to give us a time that we have to be at that point in the sky to begin our descent. And they're going to send every 60 seconds, they're going to have another plane hitting that point to then come down and go in line to land on the aircraft carrier. So as soon as I get into holding, they give me my time for when I need to be there, and I'm immediately calculating, okay, how much more time do I have before I need to be at that point? How far am I from that point? How fast am I going right now? And essentially, how do I make sure that I can get my aircraft to that point at the speed I need to be at the exact time I need to be at? And like I said before, I have a lot of instruments in the airplane that will help me calculate that. And I can put the point on the ground in my system, and I can see how far I am from that point, and I can see what my ground speed is. So how fast am I traveling over the ground at any given time? And I can continue to assess, am I going to make it? Am I going to be too early? Meaning I might need to slow down. Am I going to be late? I need to speed up. And I'll be doing all of that math, cross-checking what I put in my system, and sometimes I even use paper, and I'm just cross-checking it on paper to make sure that I've got it all right. And then it all works out great until they tell me, actually, we need you to come at a different time, last minute. Maybe they'll say, hey, we just need you to wait 2 more minutes. And so now I have to figure out on the fly. I don't have enough time to put everything in my system. I just have to change my flight path, change my speed, kind of maybe turn away from the point. And then I've got to do all of this math in my head to figure out how I'm going to make that new time. And you can see the equation on the right side there. I've got my airspeed. How fast is my aircraft flying through the air? All right. But then that's not going to be exactly how fast I'm moving across the ground. Depending on how fast the wind is and what direction the wind is blowing, my aircraft might not be moving the same direction and speed that my nose is pointing and my airspeed is telling me. So I've got to do all of those calculations to make sure that, maybe if I'm flying away from the point, but the wind is at my back, I'm going to be going faster. That when I turn around, I'm going to be going slower because now the wind is in my face. And I've got to do all of that, all those calculations, and constantly cross check so that I can meet that new time at point A, so that I am following all the aircraft in the right sequence to get aboard the carrier.
So just another reminder to our students that learning these concepts is very important before you learn how to use the tools to help make it a little bit quicker.
Yes, because like I said, your tools will help you, but if you don't have time to use your tools, or if you put the wrong information into your tools, then it's not going to help you.
Exactly. All right, here's another concept I think that you wanted to talk about.
Yes, so once we are on our way, we descend from that point A, and we've got different places along the descent route that we need to hit. But when we're coming into the aircraft carrier, it is very important that our airplane is coming in at the right glide slope. All right, so you can see, I know that a lot of the kids in this age group are learning about coordinates. And you can see there on the right, the glide slope that we're aiming for to land on the aircraft carrier is a 3-degree glide slope. All right, so that's up 1/3, as you can see, and that is what we are targeting when we're coming in to land. Now, that is going to be the glide slope of the airplane as it comes in. You can see the plane on the left. That is the path that it's flying through the sky. And the reason why it's so important is because we have a tail hook at the bottom of in the back of the airplane. You can kind of maybe see it in the picture. And it's very important that that hook hits at a perfect angle to be able to catch the wire and stop the airplane. If we come in too steep, then we could damage the aircraft. We can, hit too hard and too fast, damage the airplane, possibly hurt myself. If we come in too shallow with a shallower glide slope, then there's a good chance that we won't be able to catch that wire, and we'll just kind of skip right past it and keep flying off the other end of the ship. So the path of the aircraft flying on that 3-degree glide slope is very important. And we have to know, based on what we're looking at and what our instruments are telling us, if we're on too steep of a glide slope or if we're on too shallow of a glide slope. And we need to be able to correct it so that when our wheels hit, we're at that perfect 3 degrees. Another thing that's important is we learned about angles. All right, so my aircraft, and this is my aircraft, it's a pen today. I wish it was a cooler aircraft, but today it's going to be a pen. And if I came in on that 3-degree glide slope and I was just, my airplane was flat, you can see I'm moving at the 3-degree glide slope, but that hook point, which is going to be back here at the end, is not going to catch that wire because I don't have any angle for it to be able to hook that wire. So I'm gonna have to put my aircraft up at an angle of attack, and that angle has to be very, very specific, and it depends on the aircraft, what angle it is and where the hook is, but I'm gonna have to fly that 3-degree glide slope with the flight path of the aircraft while my angle that the aircraft is pointing is up to catch that hook. So we use angles and we use glide slope, and we're constantly adjusting them. And like I said before, we've got instruments in the aircraft that'll tell us what everything is, but we need to understand what it means and how to correct real time to make sure that we land correctly.
Oh, wonderful. I think we have some video for our viewers to see an actual landing here.
And so this you can see, this is going to be a slow motion landing of the aircraft, just so you can see the wheels touching down and the hook catching the wire. And then we land at about 140 to 150 miles per hour. And the aircraft has to stop in just about 100 feet from once it catches that wire. So It's very important that we catch the wire right on the right place on the deck, and that it, so that we can, the wire will stop us. Now, if the wire doesn't stop us, we don't come in at quite the right angle, or maybe our glide slope was a little bit off and we hit a little bit too far down the runway, then what we do is we just go full power and we fly off the front end again, and we come back around and we try it again.
Jenny, here's the last concept that you wanted to talk about as far as an aircraft carrier.
Yes, so this is a overhead view of the aircraft carrier. They are 1,100 feet long, maybe a little over 1,000 feet long. And you can see there on the bottom right of the aircraft carrier, that is the landing strip. It's a little bit angled. And you can also see that while the surface area of the aircraft carrier is pretty large, when you look, it's pretty impressive actually how big it is. With all of the airplanes we have out there and people and things moving around the flight deck, we actually have a very, very small area that we have to place our aircraft when we land in order to be able to land safely. So looking at the picture, the airplanes come in from the back of the airplane, which is going to be the top right-hand part of the aircraft carrier in this picture. And right now in this picture, you can see there's some airplanes that are parked right at the back of the airplane. We would not be landing if those airplanes were there. They would clear those out of the way, and they'd make that kind of angled strip would be completely clear. But you can see what we're aiming for is there's usually 4 wires on the deck of the aircraft carrier. We're aiming for the third of those 4 wires. And that's going to be about maybe 100 feet from the back of the deck. So if we don't have a lot of room for error. In fact, the aim point that we're aiming for is about 18 inches by 18 inches. And so when we're, despite the fact that aircraft carrier is pretty large in the scheme of things, the place that we have to put our aircraft is very, very small. You can see that if we land too short, we might not clear the back of the carrier, and we might not quite make our wheels over the deck. If we land too long, then we're going to miss, all of the wires, and we're going to have to fly around and try it again, like I talked about before. And if we go a little bit too far to the right or a little bit too far to the left, then that's when there's other aircraft and people, and it could be really dangerous. So this is just an example of, kind of surface area and how small of an area we're aiming for when we come into land.
Now, I read somewhere, is it true that a regular airport, the runway is about 13 times larger than what you land on an aircraft carrier?
Yes. A lot of the normal runways for commercial airplanes would be about 13,000 feet or more. I mean, some of them are 8,000, some of them are 15,000, but yes, 13 times longer for a normal commercial runway, and wider too. You've got a lot more width to work with as well in those commercial runways. And they're not moving through the water. They're also staying still when you land on them.
All right, Jenny. So one more question for you. I know the school districts have been very focused on the social emotional learning of students, especially since COVID. What skills do you think you learned during your educational process that helped you manage your social emotional wellness?
It's a great question, Julie. When I was in college, I was very time crunched. I was a student athlete, and I was in an engineering curriculum, and my engineering classes were really difficult. And I would usually come out of my classes the first time I heard information, and I might not have understood anything that my professor had told me, which is intimidating and frustrating. But I learned pretty quickly that is going to be the case with my engineering classes, because they're just very complex material. The way the professors present it a lot of times just didn't really click with me. And so I would have to go and talk to my other classmates, kind of get their take on what they heard, maybe review that material again with them. I had to lean very heavily on my professor's office hours to go and ask questions and get more clarification. And I just had to really kind of absorb the material myself, more than just listening to it in class. So it really taught me to just use the resources around me and really advocate for myself, and not be afraid to ask for help and ask questions, because I would not have succeeded in college in my engineering classes if I had not used those resources that were available to me. And then that translated into flight school. When I got to flight school, I really struggled in flight school with the mechanics, the eye hand, all that connecting everything. I couldn't just read in a book how to do something and then go successfully fly it in the airplane. I had to practice it, and I had to put my hands on the controls. And so I would book myself extra simulator time, and I would just go in and practice because I knew that's how I needed to learn. And some of my classmates, they could just read it, they could think about it in their head and, mentally go through the flights, and they would be successful. So I really had to learn, what tools work for me. How do I learn the best? And then I had to be, very proactive in giving myself those opportunities to learn that way and seek out those resources.
I think that's the hardest thing for teachers to teach students, is to advocate for themselves and to really take their learning, as their responsibility. And yeah, what you've talked about today, it makes my head spin with all of the concepts I could bring into the classroom and really connect and make them so relevant for the students, because they're always asking, Mrs. Rick, when am I going to use this? Well, I think a lot of us are sitting here saying, well, here are many ways that you're going to use this. And I really appreciate your time today and your expertise. And I want to thank you.
Absolutely. I'm happy to be here. And, I completely agree with you. It's hard to find relevancy sometimes, and why am I struggling with this hard concept right now? And what good is this going to do me later? But what I've really realized throughout my schooling and my career is that just working through problems and learning how to overcome difficult concepts, those are the skills that can then translate into anything and that you will use over and over again. There were some very difficult problem sets that I did in college that I probably will never see again. But the process of working through them and the skills I learned from doing that I've used every day since then.
Yeah. And just learning the collaboration and not feeling like you're the only one who needs to learn, just isolated. You reach out to your classmates, reach out to your teachers, because that's what we're here for. And it sounds like you did just that. So it's a great lesson for all of us.
Definitely.
Thank you so much.
Thank you. Happy to be here.
Brenda, thank you for your nice comment. I agree. Just seeing that math in real life, I think is just going to be so engaging for the students.
Yeah, thank you. I'm glad that we could provide some, real life examples. And if you guys look, online, there's lots of videos, lots of cool, better than even the videos we showed. Obviously, that was just very brief, but fighter airplanes, if you want to motivate your students, have something to talk about. There's definitely a lot of good material out there.
Jessica, I agree. I get goosebumps too, just watching, and thinking about Jenny flying and landing on that aircraft carrier. Very impressive.
Yeah, I appreciate the comments. It was definitely a very fun, I did a lot of hard work, a lot of, some stressful times, but a lot of really, really fun times. There were definitely times out there where, we joke that I can't believe that this is my job and they pay me to do this. And then other days you're like, I can't believe I am doing this and they can't pay me enough. But overall, very fortunate for the opportunity.
Hector, I read your question. I don't know if you can hear me well. My connection's bad, but it says, where can we get more specific info we can use in the classroom? Honestly, I think just diving in and looking at your own curriculum, because I've been thinking about this as well. Like, we're approaching a surface area section in our unit. And I just think even that aircraft carrier landing strip would be an awesome connection for the students. And just thinking about that little 18 by 18 inch target that Jenny was talking about landing, and looking at that compared to the whole landing strip, and just any concept that you can bring in. I think it's just so engaging for the students, especially to see those videos that she showed earlier. and how she lands that. And I think just getting them excited about, certain careers that use math as well.
Yeah, and I see some people asking about where the slides, where we can show the slides. I believe all of these presentations are going to be available after the expo to go back and reference, probably on the website. And I think I saw Eunice was on. I don't know if she wants to chime in on the chat. But also, just as far as if you guys wanted to, like Julie was talking about, show anything that's related to what we talked about today and videos, if you just go on YouTube and, you can just type in, aircraft carrier landings, F-18s, F-35s, you're going to find all kinds of great video that will just show little snippets and examples. Like I said, even way more than we were able to show today, that could get, students excited about this stuff.
Mm-hmm.
I see from Hurumbasi, why do you try to hit the third wire on the carrier? So the reason why we try to hit the third wire is because if we aim for the first, essentially we're giving ourselves, we have a target that is the ideal target for us to hit, and we put that third wire there. We don't want to go, we've got the first wire and the second wire as kind of, okay, we'll catch and we'll stop. And again, we want, as soon as our wheels touch the ground, we want to stop as soon as possible because of all those other airplanes and people on the aircraft carrier. So we have that third wire at our landing point, but if we land sooner, we want to stop the aircraft sooner. So that's why we have the first and the second wire. And then we have the fourth wire just past that third wire, so that if we go a little bit long, it gives ourselves a little bit of leeway. If we land a little bit long, that will still catch that final wire. But we don't put any wires past that, because at that point, we're not going to be able to stop safely before hitting that other end of the carrier. So we just say, okay, you got to go full power, fly off the front end, come around, try it again. So some aircraft carriers will only have 3 wires. Some of the older ones, and then we're trying to aim for that second wire. So they'll basically put wire 2 at the ideal landing spot, and then you've got, the first wire and the third wire as kind of a little bit of a buffer for you.
I'm glad you asked that, because I always thought there was 1 wire. I never realized there were more than 1. I thought you had 1 chance and that was it.
Yep, I'm grateful they give us a couple of options, so that we, because usually when you're coming in, you just want to stop, and we all love flying, but at that point, a lot of times we just want to stop and be done flying. And if we have to go around again, we'll do it, but we like to stop. And I, really appreciate the time and being able to talk to you guys today. Thank you all for joining in. And it's been awesome working with Julie. I said she's the educator of this group who understands all of this, and I just really appreciate being part of your world for a little while.
I appreciate you sharing it with us. Thank you, Jenny.
Thank you. Thank you, everybody, for joining.